since you are talking about contours, what meter contours would you want?
Well, I tried 1 meter and 3 meters. This is quite flat some places.
So 1 meter we need to see something. Okay. Generating contours that look nice and are correct is a bit of a challenge. Like cartographic contours that you see on hiking maps are usually smoothed out a lot so they look pleasing. They're not entirely correct anymore, but you probably don't care about plus minus half a meter when you're hiking. But you do care about easy understanding of, is it going to be steep, it's going to be super steep, or it's going to be a nice walk in the park. In LastTools, there's a tool called lasthin, which can prep the LiDAR points to make better contours. We haven't used lasthin yet, so that's the opportunity of Louis bringing it up to teach you something else that I don't know if you have used it before. So lasthin has the option contours. And if you want to make contours which have an interval of 1 meter, you can kind of optimize your points for that. Lasthin operates with a grid size, and let's set that grid size to half a meter. So what lasthin will do, if you ask for thin for optimized contours, it will thin for contours, it will thin for points that are as far away as possible from the contour, from the places where you want the contour. Because you get wiggles when the sample points are close to where you compute the contours. And the farther the sample points are away from the contours, the more stable the contour becomes. Now, this is again a case where we need to use the buffered points as input, because lasthin generates temporary. Think about that. No, we don't. Not this one. If we use adaptive thinning, then yes. But for contours, it just looks in every grid cell of half a meter. It tries to keep the point that is as far as possible away from the even number 1 or 2 or 3 or 4. So it tries to keep a point that is either at some number 0.49 or some number 0.51, far away from 0.0. That's sort of the, so we can use the final points because it doesn't require neighborhood information. And we only want to thin the ground points. So we filter the ground points. We're basically going to create some temporary points now that afterwards we throw away when we're done creating the contours. We keep only the ground points. And from all the ground points we keep, we will keep the one that's best for contours on a grid of half a meter. And as input, we use the final tiles. Because we need the elevations, obviously. We don't want the buffers, so we don't, otherwise we have to remove them again. We could use the buffer points too, but then we have to remove them before we do the blast2iso, because blast2iso merges everything. And as the output, we should create a temporary folder. So I'm just going to create a temporary folder called four tiles. Oh, I'll describe it anyways. I'll say thin for isolines 1 meter. Now I know in there I have points which are thin to make isolines of 1 meter. Of course, those are only the ground points, but usually when you create isolines, you only use the ground points. That's kind of understood. Making isolines of a digital surface model gives you lots of isolines. It looks really cool, but it's not really useful. So here it is, files thin ISO 1 meter. That's my output directory. The filter is here. I can now run on all the cores, and the points which I don't use I will remove, which is okay. Run. So what do I do? For all these final tiles, I keep only the ground points, and I drop the ground points on a grid of 0.5 meter, and I then keep the point that's best suited for making contours of 1 meter, and I output those temporary sub-sampled point sets to a new folder. And in the next step, I will use those temporary files as input to create ISO contour lines with 1 meter spacing. And I should only use those for 1 meter spacing because they have been now optimized for that spacing. The other way to look for the progress, you can see how many files you have here. Oh, just done. I'll quickly have a look at one of these outputs. Okay. If I triangulate that, okay, still looks like valid ground. And now I run blast2iso. Blast2iso. Again, the blast instead of the last. That's part of this streaming tin. Look for the tool, blast2iso. It's at the very top when you order it by name. And now as the input, I use these temporary points. The temporary tiles. And they still do have the projection. So I merge them all into one. I call the output, well, first of all I want to use KML output so I can overlay it in Google Earth. I want to have every n units, every 1 unit, that needs to be the same now as the one that I optimized it for. Every 1 meter I want to have a contour line. I want to output it into the same directory where the DTMs are, into that main directory here. And the name I want to give it is maybe ISO 1 meter dot KML. Oops. And then there's a few things you can do to make it even prettier. You can smooth the tin a little bit, maybe only 1 pass. And we can do some removal of short lines. You know, if you have a very short line somewhere, it's maybe just a little circle. This is in meters. Any isoline shorter than 5 meters gets removed. You can simplify a few things. These are things you should try out. It's different on every data set. Flat data sets are always a bit more tricky. I like showing demos with very big mountains because then the ISO contour lines always look really beautiful. It won't be so beautiful here, I think. Run. So blast2iso, again, I'm merging that. That's important, so I have one seamless ISO contour line set. I want ISO contours every 1 meter. I'll smooth them once. I'll simplify them a little bit. I clean the short ones and I output it into this directory. You can look at our progress bar. Yeah?
Can you show the common line again?
No, it finished. I can show it again without running it. So these are the temporary created one, merged into one. Every 1 meter the isoline, then I just enabled all these options. Smooth, simply, I mean, if you don't have them, it shouldn't make too much of a difference. Yeah. And so, where's the result? The result should now be in the 2013 folder called ISO 1 meter. Here it is. Yeah. I need to change it for prioridades, and then I can say altitude always on top. Where do I see that? Absolutas no. Yeah? Okay. Because it's almost correct, but not quite. It doesn't quite align there. Yeah. Maybe we should have smoothed some more. But yeah, there's still a lot of stuff in on the terrain. You see these. If you see in the hill chain, there's all these structures. And all these structures are affecting the contour line. And as you see, in the steep areas, where it's a bit more steep, the contour lines are very pretty. But you come to the very flat area, and the contour lines just look really sucky. And, well, what are you going to do? In the flat area, the contours are not well defined because you just wiggle it around and change this one. So, what we learned from this, try to work in terrain that has some nice, more geared, very beautiful contour lines along the steep areas. When you get to the flat areas, this doesn't look so nice anymore. Here, very pretty in the steep areas. chosen to be visible over there. Now this is not so visible anymore. Now the yellow appears again. And yeah. So that's how you create island contour lines. Bridge. See, there's no contour line crossing the bridge.